And we're back. We're now going to edit the parameters for our copper run. So I actually want to do a background deuterium correction. I prefer this over the SR method. So we'll just select that. And then we're going to click line search. So what's going to happen is it's going to take a while again. The hollow cathode lamp is lit. The light emitting from it is sort of optimized using this line search, making sure that the wavelength is appropriate and that the beam is balanced with the background. So we're optimizing our signal. All right, so you'll know that the line search and beam balance has completed when you see an OK next to each of these. And at that point, you can click close. Then we're going to move to the sequence tab. Make sure that using ASC is checkboxed. If you're running more than one element, at the end of measurement, you would select continue. But since we're running one element, we don't need to worry about this. If you are running more than one element, you're going to want that second lamp to warm up. Only one lamp can warm up at a time. And so you would change this to 5 minutes, the lamp warm up time. In the repeat measurement conditions tab, we're going to change the number of replicate measurements to 3. The number for the blank, the standard, and the sample. We're going to change the RSD limit, or the relative standard deviation limit, to 2%. This is a percent. So that tells us that if our relative standard deviation for these 3 replicates is above 2%, it's going to rerun the sample again. And we want the standard deviation limit to be 0.007 for the blank, the standard, and the sample. Again, if the standard deviation is above this value, it'll rerun that sample. Okay, and then we're going to look at the measurement parameters. We want sample, and then M, and then M. We want the SM, M, M repetition sequence, and I'll tell you more about that in a minute. We want a pre-spray time of 10 seconds. So this pre-spray time is pretty interesting because this relates to how long the instrument waits before taking a measurement after putting the tubing into the sample itself. If the pre-spray time is too short, you can see some funny effects. We're going to leave the integration time at 5 seconds and the response time of 1. In the calibration curve parameters, we can select our concentration units. I'm going to use parts per million. Calibration curve is, and we're not going to force a 0 intercept. So here we can click OK. Then we're going to click Next. We can set up our calibration curve standards. So right now we're using 4 different standards. The default is 4 standards of 0.1, part per million, 0.5, 1, and 2. You can change these to whatever you've prepared. I wouldn't go too far above the maximum parts per million that's given for the calibration curve, simply because if you go too far beyond, you're going to be outside of the range of linearity. You can also give the sample ID a name. So you can even just name this 0.1 parts per million, something like that. Okay. And then in the sample group setup, you can choose the number of samples that you're going to measure. So right now it's going to do 10 samples. If we only want 5, we'll put 5 in the number of samples box and click update. So now there's only 5 in our list. You should give each one of these a name. If you don't do it here, you can do it in the table on the software itself. But make sure you do label them in some way so that you know what each sample corresponds to. The other thing is you're going to want to make sure that the position is correct. This position corresponds to the position on the auto sampler. So if the Copper sample 1 is in position 1. Make sure that that's how it looks over there on this auto sampler. And then click OK. And click Next. And then connect and send parameters. Click Next. Oops. Sorry. Click Finish. And then it will populate this table. And these are all the standards and the unknowns that we've set up. If you've given these all names, all the names would appear here with their true values for the standards listed as well. So here's what the table will look like. It's going to have all of your standards listed. If we'd given them names, they would show up in this column. All of your unknowns. Your standards will have their true concentrations associated with them. And then to run your samples, run your sequence here, you would just click Start at the bottom of the screen. Okay, so we're waiting for the instrument to begin to run. Right now it's filling the rinse port with water. How do I know that? It says right down here at the bottom. I wish this was a little bit bigger and more noticeable. It often feels like you're just waiting for the instrument to go and you don't know if you did everything right, but check that bottom bar on the software if you have questions. Now it says rinsing nozzle. Okay, and so we should now start seeing some data on the screen. Well, this one isn't very exciting, I guess. It's a 0.1 part per million, which has very little signal. Okay. So in these windows, this is the absorption versus time. It's much more noticeable once we get further along here in the system. So maybe let's look over here. So we can watch our auto sampler run for a little bit. So it's in the second standard now. This is 1 part per million. There's a 10-second pre-spray time. So during that time, it's not actually collecting data that will be used in our calibration curve anyways. Once it's done collecting the data for that sample, it rinses the nozzle in the rinse port. All right, so now we're starting to see some data on the screen. So here we have our first data point at the 0.1 part per million standard. Here's the 1 part per million standard. So this is building the calibration curve. The equation for the line is at the top and the R² value there. This plot's interesting because it shows the signal over time throughout the duration of the experiment. So you can see when we're rinsing and when the sample starts to enter the flame. Again, rinsing, you see the signal tapering off. This is also signal and background, so blue is the background. But I like this plot.